today's video, I'm going to do test a review on DC fundamentals. So the main topic is about Ohm's law, power law, now let's look at question 1. So we have a circuit shown parameters. So let's say we have a circuit like this. Have one resistor here, we have another one more, another power source. So this is the ground, this is the ground. So we have E1 equal 24 volts, E2 equals 42 volts. We have R1, R2, R3. This is the point A, this is the point B. So we have R1 equals 500 ohms, R2 equals 800 ohms, R3 equals 300 ohms. So if we have a circuit like this, so the question 1 is the current direction. So when we need to find out the current direction, we always start with the high potential. So E2 is, since E2 is greater than E1, so the current direction will be the same as the E2 positive side. So that will be from here to here. That's the current direction for I. Then we need to find out I, the current I. So I will equal to E2 minus E1 divided by R1, the total resistance, plus R2 plus R3. Since they are in series, so R2 will be R1 plus R2 plus R3. By using Ohm's law here, we can find the current. So E2, 42 volts minus 24 volts divided by 500 ohms plus 800 ohms plus 300 ohms. That will give us 11.25 milliamps. After we get the current, we can find the VA. VA will be, so the voltage at point A so we have the current here, we can find the voltage drop here and then E1. So VA will be E1 plus I times R1. So that will be 24 volts plus 11.25 milliamps times 500 ohms. That will give us 29.625 volts. So we also need to find VB. VB will be E1 plus IR1, or VA plus the voltage drop. So this part will be a VA plus a voltage drop for R2. So I times R2. So that will be 29.625 volts plus 11.25 milliamps times 800 ohms. That will give us 38.625 volts. So that's VB. Basically, we follow the current direction, find the voltage drop. so it'll be E1 plus IR1 plus IR2, or it will also be VA plus IR2, the voltage drop on resistor R2. And we need to show the power. So the power is the formula for power, P equal to I squared times R. Also use E squared divided by R. We can also have EI. All these formulas are kind of based on the Ohm's law. So let's say P equal to I squared times R. If we need to replace I with E, so I equals E divided by R. So if we square R, then we can cancel out 1R from that will be E squared divided by R squared times R. Then we cancel out 1R. That'll be E squared divided by R. And same thing, if we want to replace R, that will be I squared times R will be E divided by I. That's R. So we cancel out 1I, that will be EI. If we have P equal to EI, let's say if we want to replace E, so E equal to I times R based on the Ohm's law. So I times R times I, that will be I squared times R. If we want to replace I, we have E times E divided by R, Ohm's law. So that will be E squared divided by R. So the power, total power P source, which is the E2, so that'll be E2 times I. That will give us 42 volts times 11.25 milliamps, which is 472.5 milliwatts. So the standard unit for the power is watts. If we have milliamps times volts, that will be milliwatts. If we have milliamps times milliwatt volts, that will give us, kind of microwatts, because we have milli that will 10 to the minus 6, which is a micro. If we have amps times milliwatts, that will give us milliwatts here. So P used, which is all used, will be E1 times I plus I times R1 plus R2 plus R3. These are consumed power. So this is the provider power. These are used power. So the total will be same thing, so 24 times 11.25 milliamps plus 11.25 times 10 to the minus 6 or 3 square, then times R1 plus R2 plus R3. After we plug in the numbers, we should get the same number as that, because the total power provided should be equal to the total power used. Now let's look at the other circuit. So for the unknown, voltage, VR and Vx. So let's say we have circuit, the power source here, let's say this is kind of a resistor R, this is E, and we have another resistor. So VR, this is VR, this is Vx, and we have R equal to 50 ohms and P equal to 100 milliwatts. And this is the current direction, I. So we need to solve for Vx and Vr. First thing, we have the power for R. We have the power and we have the resistance. So P equal to VR squared divided by R. If we have this formula, now we need to solve for VR will be equal to square root P times R. So that will be square root 100 milliwatts times 50 ohms. So that will be square root 100 times 10 to the minus 3 times 50. That will give us 2.236 volts. And for Vx will equal to minus Vr minus 3, then plus 12 volts. So we have, this is 12 volts, this is 3 volts on this direction. So Vx, total Vx on this direction will be minus Vr, then minus 3 plus 12. So that would be minus 2.236 volts minus 3 volts plus 12 volts. That will give us 6.76 volts. So that's for Vx by using KVL, Kirchhoff voltage law. So if we have a loop here, Vx minus 12 plus 3 volts, then plus Vr will equal to 0. That's by using KVL. The whole loop voltage follow the same direction will give us 0. So Vx will 12 minus 3 volts minus Vr. Number 3, we have a given circuit. And solve for the unknown. So let's say we have circuit like this. Have another resistance. So this is basically the parallel circuit. We have R1, R2, R3. This is E. We have the total current here. So I equals 220 milliamps. We have R1 equal to 40 ohms. We have R2 equal to 200 ohms. And this is the current of 130 milliamps. So this is I1. This is I2, this is I3. So we have total current I. We have resistance R1, resistance R2, and the current for I2 and I3. This is a parallel circuit. So IT equals I1 plus I2 plus I3. And we have, on the diagram, we have the current for I23, which is I2 plus I3. IT is 220 milliamps. And I2 plus I3 is 130 milliamps. So from there, we can get I1 equals IT minus I23 equals 220 milliamps minus 130 milliamps. That will give us 90 milliamps. So that's the current for I1 by using Ohm's law. we can get the voltage for R1. So V1 equal I1 times R1 equals 90 milliamps times 240 ohms. That will give us 21.6 volts. And since parallel circuit, the voltage are the same everywhere, so E equal to V1 equal to V2 equal to V3. Then we can get the current for R2, I2 equal to E divided by R2, which is 21.6 volts divided by R2 is 200 ohms. That will give us 108 milliamps. And I3 is I23 minus I2, or we can also use E divided by R3. But we don't have R3 yet, so we should use I23 minus I2. That will give us 130 milliamps minus 108 milliamps, so that will be 22 milliamps. So that's the total current for I3. Then we can find R3 by using Ohm's law. So R3 equals E divided by I3. That would be 21.6 volts divided by 22 milliamps. That will give us 981.8 ohms. So till now we find all the elements here. We find the I1, I2, I3. We have R2, R1. We find R3. We also find E. So that's kind of every element for this circuit. Now let's look at another one. Determine the unknowns. So we have the power source here, resistor, another resistor. So we have E equal to 52 volts. We have R1, 2 kilo ohms. We have R2, equal 4 kilo ohms. We have R3 equals 2 kilo ohms. We have RL, which is 2 kilo ohms. So this will be IT. This will be V2. And this is a V3. And we have RT here. So this is a combination circuit. We have R3 and RL in series. Then in parallel with R2. After we get that, then everything in series with R1. So in order to find the equivalent circuit, we do R3 and RL in series first. So let's say RA equals R3 plus RL. That will be 2 kilo ohms plus 2 kilo ohms. That will give us 4 kilo ohms. Then in parallel with R2. So let's say it's RB equals RA parallel with R2. That will be RA times R2 divided by RA plus R2. Since they have the same number, so 4 times 4 divided by 4 plus 4, that will give us 2 kilo ohms. Then RT, which is, let's say, RC equals RB in series with R1, so RB plus R1, so 2 kilo ohms plus 2 kilo ohms. So the total will be 4 kilo ohms. After we get the total resistance. We can get the total current IT by using Ohm's law. That will be E divided by RT, which is 52 volts divided by 4 kilo ohms. That'll give us 13 milliamps. So we get the total current here. Then we can get the voltage drop. After R1, let's say V1 equals IT times R1. Because the R1 is in the main branch, so it will be 13 milliamps times 2 kilo ohms. That will give us 26 volts. Then for the voltage for the parallel part, so that means this is 26 volts, and the whole thing here is 26 volts. So we can get V2, basically V2 is a minus 26 volts because it's a kind of on the opposite V2. So V2 is 26 volts, and we can find the current for R2. We can also find the current for RL and R3. So the total voltage for R3 and RL is 26 volts. We can find the current for that. So the current for IL3 will be E minus V1 divided by R3 plus RL. That will be 52 volts minus 26 volts divided by 2 kilo ohms plus 2 kilo ohms. That will be 26 volts divided by 4 kilo ohms, which is 5 point. Which is 6.5 milliamps. Then after that, we can find the voltage for R3 by using Ohm's law. So that would be IL3 times R3. That would be 6.5 milliamps times R3 is 2 kilo ohms. That would be 13 volts. And if we given the series voltage, that's number 5, given the series voltage.
Okay, I found this on the web for what is. Check it out.
So number 5, we given the series
Hello there, I'm Siri. What can I do for you?
So number 5, given the theoretical voltage across resistor is 16 volts, but the voltmeter reading is 15.6 volts. What's the deviation? What's the error? Do we need to calculate the error, which is the deviation? So we use the theory for the deviation. We use the theory minus the measurement, which is a voltmeter reading. Divided by theory, then times 100. So that will give us 16 minus 15.6 volts divided by 16 volts times 100. And the unit will be percent, so that will be 2.5%. So that's all the questions review for test 2. If you have any other questions, you can leave a comment. Good luck on the test. Thank you for watching.